Good evening, everyone. Tonight, I'd like to go over Chapter 1. Um, the topics would be how what happens to database. You will have, as you can see, the picture, figure -1-1. You will see user connect to the database. So there's a front end, the user. User will use an application to connect to the server process. And the server process will have an instance, and the instance is connected to the database there. So what happens from user to database? As you can see that there's called the session components. Session components would be a browser. User can access the database through a web browser or SQL Plus, SQL developer, some kind of software. It can be anything. Web browser. If you buy an item from Amazon.com, you buy that from a web browser, right? So you can think that as a user process. User process can be a web browser, SQL Plus, or SQL developer software. The software is connected to the server process. So what we call is session components. So between the server and the client, web browser, there's called the session component. So that server and user will communicate through the web. So when you connect the server process is also connected to the instance. We call that instance because you can have multiple instances on database. On database, you can have one instance is the can you think of the way you connect to the DVC Oracle dot server? One instance name is do you recall the CS150 SID? That is an instance. That's one of the instances I have on the server, Oracle server. So you can have multiple instances on a server, and each server can have server process. And the server process, it will manage all the connections from users, meaning there are multiple users connected to the database, right? And their Amazon.com website, there are a number of users buying items. So they opened a number of web browsers, right? So you can think that as multiple user processes, and multiple processes are connected to the server process. So now let's look at the 1-2, the picture there. So on this picture here, the connection pooling model, you have multiple browsers open connected to the application server. The application server is connected to the database server. What it means is that you have usually application server can be Tomcat, IIS, Microsoft IIS. That is web server, Microsoft web server, and Microsoft web server is connected to the database. So you can see that multiple browsers connected to one server, web server or application server. We call that a stateless, non-persistent session over HTTP. What it means is that the connection to the application server is not always connected. What happens is it will keep a session ID, and once the user requests, oh, I want to buy this item, do you have this item in stock? Then the user enters the item. Then the information is sent over to the application server. Application server will check with the database with the number of items they have in stock. Meantime, the connection from browser to application server is not always connected. Temporarily, it receives a request, then it disconnects the connection. And once it receives a response from the database, the application server will send that information back to the user browser. So it's not connected all the time. It's temporarily connected and disconnected. So it happens all the time. Connects, disconnects, connects, disconnects. That's what we call connection pooling. So one application server can communicate with multiple browsers, multiple users. So the application server does not have all the connections open. It may have 10 connections at one time, but it can support 100,000 users with 10 or 20 connections. What happens is that whenever the first user requested, it disconnects and check with the database and sends back. So meantime, just it connects only milliseconds. Then it replies to the users. So that's what we call connection pooling. Application server has maybe 10 or 20 connections it can open, but there are 1,000 users try to get the information. So it has to use the in order to support the 1,000 users, it has to use the connection pooling. So temporarily use one of the 20 connections application server has and respond whichever is open. That's what we call connection pooling. It is possible you can set the number of connections you can have on application server, but we'll not go over detail. But you can set it up on the application server, web server, number of connections you can establish. Now let's look at the 4 types of commands. As you can see that there are DML, data manipulation language, DDL, data definition language, DCL, data control language. And the last one is transaction control language, TCL. So let's look at a few things in DML. Select, insert, update, delete, merge. These are considered DML, data manipulation language. What is the difference between DML and DDL? Create, DDL includes create, alter, drop, rename, truncate, comment. All these are considered DDL. The major difference between DML and DDL would be DML, you cannot roll. When you use a DML, it is possible to roll back using TCL. One of the commands you can see, TCL includes commit, rollback, save point. By using the TCL, it is possible to roll back after using DML, data manipulation language. But once you create, alter, drop, rename, truncate, when you use these commands, DDL, you cannot roll back. You cannot roll back the transaction. Once you use the commands, create, alter, drop, these commands, DDL commands, you cannot roll back. When you use a DML, it is possible to roll back using the TCL commands. Let's look at the data control language, DCL. Grant, revoke are considered data control language because it grants the permissions you allow other users to access your tables. If you want to do that, then you use the command starting with the grant certain table to the user. So you use the command starting with the grant. If you want to revoke certain users from accessing your tables, then you would use the revoke command. So if I ask a question, the difference between DML and DDL, the major difference would be DML, it is possible to roll back the transaction, whereas DDL, you cannot roll back. Let's look at the next slide. This is the common receipt. You will find that the grocery store or like banks, the you will get you will see the field name is name, street address, city, state, zip, and each one name is considered a field. Street address is also considered a field. City is a field. State is a field. Zip is a field. When you combine all these, name, street, city, state, zip, it is considered a record, right? So if I ask you to create a table, how do you create a table? What are the what kind of name would you put it in? How would you name the table? What are the columns? If I ask you to this is the information we need to store in our database. So I ask you, how do you create a table? Then probably first column name would be name. Second column you probably want to call street address. Third column city. Fourth column state. Fifth column zip. So what do you call what do you call a record? This is a logical design. Fields, record, these are logical names. What about the physical design? Physical design is the actual table. You call a table as let's look at the record. How do you interpret record? Record is a logical name. What is the physical name for record? Record would be, we know the column name. We have 5 columns: name, street, city, state, zip. These 5 columns. Now, if you have all these, name, city, state, zip, then it's called customer 8. It's also called row 1, ROW. Customer B is row 2. Customer C is row 3. So all these customers, number of customers, are, we call that logically, what do you call that? File. So file is comprised of number of customers. Each customer is, we also call that a record. A record is comprised of number of fields, such as name, street address, city, state, zip. What do you call we know the file is a logical name. What about the physical name for file? Can you think of a name? A file is a table. Record is a row. Field is a column. Now let's look at the entity ER model notations. ER model notations means entity relationship model. We call that because you will have a number of relationships. You create a number of tables, right, using the scripts I posted on the website. Now think about the tables. There are relationships between tables. Now, how do you indicate? How do you make a notation? We call entity, and there's dash one-to-one relationship. We call notation dash. Solid line, one-to-many relation, one-to-many. So you have a line with the number chicken tracks, right? Many-to-many relationship, chicken track to chicken track. So we call many-to-many relationship. And there's an optional dotted line. Now, how does it work? Well, let's look at the next slides. Figure 1-3 and an ER model for just lead books. Let's look at this one here. You have a publisher. A publisher can, then you see the chicken track to the books, right? That means, what does that mean? Well, one-to-many relationship. Publisher is one, books many. What it means is that publisher can publish more than one books. So you have one-to-many relationship. What about the books? What's the relationship between books and author? It is a many-to-many relationship. Why? Well, author can publish more than one books, and the books can be published by more than one author. So you have many-to-many relationship. What about the orders between? What is the relationship between orders and books? You have many-to-many relationships because books can be ordered. Um, well, single order can have multiple books. So you have a single order can have multiple books, and the book can be ordered by multiple orders, right? So it is the not many-to-many relationship because one book can be ordered for John, and one book can be ordered for same book can be ordered to Smith, Sue, John, Mary. So single book, same book can be ordered to number of people, and each order can have more than one books. That's why you have a many-to-many relationship. And customer to orders. A customer can make a number of orders. I can make an order just single time, one time, but I can make more than one order. That's why you have entity ER model. This is the basic first step you design. Then this is the like a logical designing, and the physical designing would be you actually you create a columns and tables. We call that entity and attributes. Each table must have entity. Let's look at this table here. Um, just leave books a table I just created here, a table with ISBN column 1, title column, publication date column, cost column, retail column, category column, publisher column, contact column, author column. Now, what is the name of this table? How would you name it? Let's say you design a table and you have all these columns there. How would you name this table? Well, probably you want to name it in a books table. Why? Because you have ISBN. All these are kind of describing books. So let's say ISBN. ISBN is unique, right? Each book can have only one ISBN, and you have a title, publication, cost, retail, all these. What do you call, if there's one entity here, what does that mean, entity? Entity is main, usually with a unique value. Usually you can see the ISBN, is it unique? Title, is it unique? Publication date, is it unique? Cost, is it unique? So all these columns, you look at them, and which one can have a unique value per row. So ISBN is unique. So book table will have ISBN. ISBN would be the unique. So you can have a primary key on ISBN because primary key is unique. So let's say you have a book table with the ISBN as a entity. Entity is a column with the primary key, usually, not always, but usually with the primary key, a column with the primary key would be an entity. So you have the ISBN and the title, publication date, cost, all these other than ISBN. We call these columns attributes. Attributes are describing the entity. So you can see the title, publication date, cost, retail, category, publisher. All these columns are describing ISBN. So you can think that as ISBN an entity. Table name is books. Let's look at the author column there. How many authors do you have? You have T. Peterson, J. Austin, J. Adams. And second row, you have W. White, L. White. Well, it looks like so strange. Why? Well, you have multiple values, multiple authors per row. So this is considered a normalized table. A normalized table means it is violating. You're supposed to have one value per row, but you have multiple author names in a row. So that means you have to go to normalize. First, you have to go through N1. Let's look at the next figure 1-5. You can see the books table from figure 1-4 after conversion to one normalized form. What does that mean? Well, you can see them. They are almost identical to the previous one, except when you look at the author, you have P. Peterson, J. Austin, second row. Third row, you have J. Adams. Fourth row, you have W. White. Fifth row, you have L. White. This is the first normalized form because you must have a single value per row. So after you complete that, you consider that as the first normalized form. Well, let's look at the, do you stop at the first normalization? Well, definitely you want to go up to the third normalized form. So this is the first step. When you have a normalized table, you do not want to stop at first normalized form. You stop usually on the third normalized form or fourth normalized form. Most people, they stop at third normalized form. So let's look at the next slide. So when you look at this one here, this table, now you have ISBN column, title column, publication date column, cost column, retail, category, publisher, contact. So what happened to the previous slide? What happened to the author column? Well, if you have, when you look at the figure 1-5, you're wasting a lot of table space, right? You have repeating tables, repeating rows, right? You have first row and second row. First row and second row, what's the difference? Only the T. Peterson and second row with J. Austin, all identical, like ISBN number, title, publication, cost, retail, all same except author name. So you basically, if you store them like this, you're wasting a lot of table space, wasting resource. So you want to normalize it, but you don't want to waste your tables space. So when you go into the second normalized form, you will remove the author column. So you don't want to lose the author information. So what happened to the author column there? What you're going to do is probably you want to create an author table, and you will have the author's name as the primary key on that one. So you can have a relationship between books and author. So now, by removing the author column, now you have only 2 rows in the books table. And you're not wasting your space. So this is the second normalized form. So I mentioned you usually stop at the third normalized form. So second normalized form, we call this after elimination of partial dependency. So partial dependency is the author column. By removing that, we completed second normalized form. Now, what is the third normalized form? Well, third normalized form would be what you call that transitive dependency of publisher contact person is removed. What it means is that when you look at the figure 1-6, you have a column called contact. Contact is not directly related to the ISBN, meaning that you can have a title, we call that attribute. Publication date, you can call that attribute. Cost, attribute. All these columns are describing ISBN, the book, but contact does not describe the book, meaning it's not directly related to the ISBN. What happens is that when you go through the third normalized form, you remove that column, contact information, and you keep only directly all these 2, 4, 5, 6 attributes: title, publication date, cost, retail, category, publisher. These are considered attributes. All these attributes are describing the entity ISBN. So by doing this, you completed third normalized form. This is usually developers, they stop at this third normalized form. So why do we need to go through the normalization? Well, by doing the normalization, we remove the redundancy. What does that mean, redundancy? Well, when you have before a normalized table, look at the figure 1-4, just leave books table. You see that author has multiple values. If you have multiple values in a single row, it is considered a normalized table because it is hard to search for the specific author. So by having only one value, it is possible to quickly search for that author name. By going through the normalization, we remove the redundancy, save space, and by